Hello and Assalamualaikum. My name is Badru Ajmal bin Abdul Rahman. My metric number is S7710 and I am from Group K2. Today I will be presenting my individual assignment for ACT 3 5.3. The main objective of this video is to demonstrate my proficiency in relational database, which in the context of accounting information system. I will be showing case my digital skill by utilizing Microsoft Excel for problem solving, especially focused on problem 4.10. Problem 4.10 requires us to manage a database that store important information about borrower, lender, and appraiser. Through this video, I will explain my step-by-step process of designing the database structure, normalize the table, input the data, and finally execute 6 different inquiries to extract meaningful information. Okay, let's begin with the task 1 and task 2, which involves identifying the required table and developing the database. In Microsoft Access, I create 3 separate tables: the lender table, the appraiser table, and borrower table. I went to the create tab and use design view. For a database to function correctly, we must adhere to normalized principle. This means eliminating any redundant data. In the lender table, I set lender ID as the primary key in the prices table. Price ID is and prices ID is the primary key. This key unit see and refer each record. The next step, first we must go to create and click query design and change to SQL view. For the task 3, we will extract data for creating query using SQL view. Let's start with the query 1. The question asks moving on to data entry. As you see, an important key in the data provided in the assignment into the datasheet view. Since data entry can be time consuming, I have fast forward this section. However, I want to explain my strategy. I made sure to enter data into interdependence table first, which are the inlander and appraisers table. Only after two are complete did I enter the 12th record into the borrower's table. If we do it to another way around, Microsoft Access will be block the entry due to the references intelligence rules we set earlier. Now the process is complete. Let's take a look at the final table. All important part of the data has been recorded accurately without any spelling error, ready to query. Next, I will establish the relationship and connect the primary key from the lender appraiser table to foreign key in the borrower table. I also check the enforced reference integrity box in the accounting system. Reference integrity is vital because it prevents open record. For instance, we cannot have a borrower reassigned to a lender that does not exist in our system. Start with query 1. The question asks which borrower used and send a price. I wrote a select statement to receive the borrower ID, last name, and a price name. I use an inner join to connect the borrower and a prices table. In the where clause, I sprite and a condition to equal advisors advanced prices. Click and run. Here is solution output is datasheet view. Moving forward to query B, we need to list appraisers with the letter D in the dear name. In the SQL view, I use the like operator combined with a static wildcard. We must to bracket in D. D is marked as a way to find a specific letter anywhere in the text. I also use the order by clause to show the result operation and click run. Here are the results. Okay, we move forward to query C. We must list lender involved in the transaction with appraiser ID 8. This requires join the lender and the borrower table. The where clause to filter the record officially for the borrower appraiser ID equal to 8. The datasheet view specially display the lender name, borrower ID, and the managed montage amount. Okay. Next is query D. The objective is to list lender that lend more than 1,000, showing each a combination of lender and appraisers only once. To achieve this only once I use the indistinct keywords in my selection statement. I join all the three tables and set the condition equilibrium amount more than 100,000. As you can see, there is no duplicate combination in this output. Query E, we need to find average amount of borrow from each lender. This is more complex. I use the AVG aggregate function to calculate the average. To present it currently at the two chemical place and request. I rewrap it into round in bracket function. I also use the group by clause to group the data by lender ID and short it to the census order and click run. Here is the financial breakout. Is query F. We want to know how many appraiser performed. I use the count function and the borrower ID to tally the transaction and group the result by appraiser's name. The output provides a clear performance metric for each appraiser. The conclusion is using systematic building this relationship database is cross strict normalized and SQL command carefully. I was able to solve all the requirements for problem 4.10. That's all for me. Thank you. Thank you for taking the time evaluation my presentation. Thank you for that. Have a nice day. Thank you.